Hey everybody, I'm Taylor Sparks and I have another really cool video today about ChemSolve. ChemSolve is a really cool bit of software that comes from the McQueen lab. So Tyrel McQueen at Johns Hopkins University wrote this really useful bit of software, which is honestly I still use it today. If you're doing stoichiometry calculations, I know you can do them by hand. In fact, check out below. We have a video where we show you how to do it, but it's really useful to double check your answers using ChemSolve. Here's how it works. You type in what it is you're trying to make. Like here, let's say we're trying to make YIBCO, YBA2, copper 307. Technically, you could put Y1 here to differentiate, but it will know that it's talking about yttrium and barium. It does a pretty good job if you leave that out. And then you say that what your starting materials are. In this case, we're starting with yttria, Y203, barium carbonate, and let's say copper nitrate, and then it has a hydrate where we're going to have that it's 3.261 is the value of this. So you'll saw it before in our previous video that this value of X with hydrates is sometimes ambiguous and you have to determine it yourself. So in our previous video, we showed you how to do that. Essentially, you take some known amount of hydrate, you fire it, you figure out what it produced, in this case copper oxide, you weigh that very carefully, and therefore you know how many moles of copper must have been in the nitrate, and you know how much you weighed in there, so you can actually extract out the molecular weight and therefore the amount of hydrate. Blah, blah. So check out the video below. Anyway, so here's our starting materials. And then you have this really important box here that says do not balance. This is things where you're basically saying like, don't try and balance the chemistry here. For example, don't bother balancing CO3 units, just make those equal to oxygens, right? And don't try balancing NO3 units, right? The nitrate groups, because they're gonna burn off and form NO2. Like the CO3s are gonna burn into CO2. NO3s are going to burn off. We're just going to not balance those. And also the water. We're going to tell it to ignore water. So we're going to say also H2O, just treat that like oxygen, and we're not balancing oxygen because we're assuming that there's plenty in the air. Okay, and then you're going to say, you can ask it, how much could you make with a given quantity of starting materials, or maybe you want to make, if I want to make 5,000 milligrams, so 5 grams of product, how much do I actually need for these things? Well, check out how cool this is. It shows you right away. It says, okay, I'm treating Y203 as a source of Y2 because it needs yttria in the final product. I'm treating barium carbonate as just barium. I'm ignoring the carbonates. I'm treating this whole copper nitrate hydrate as just copper sources. And then here's my final formula where it's ignoring the oxygen and figuring out how to calculate that. So this shows you the exact amount of these different things to add. So in this problem that I gave you to work out in my other video, I basically had them figuring out which one of these three is the limiting reagent, and then once you know that, how much could you make? But here you can actually see, you can say like the ratio of yttrium to barium to copper reagents, you can see what their ratio is versus the actual one, so you very quickly be able to see which one's your limiting reagent. Okay, so that is ChemSolve. I hope it's a useful tool for you. I use it all the time.